fish population doubles every 5 years. There are 2,000 fish today. How many fish will there be in 6 years? Then, how long will it take our population to get to 32,000 fish? First thing I do, okay, this is an exponential growth problem. This is coming from the differential equation. Y prime equals C times Y. So the rate of change is proportional to Y itself. Our solutions are going to be the form Y of t, okay, t since we're using time, equal to A0, which is our initial population, times e to the constant times t. So we're going to need to solve for a bunch of items in this equation to get to our answers. So to start off, let's see what we're given. Okay, well, we're given the fish population doubles every 5 years. We'll hold on that for a second. That's where we'll need to do some work. Okay, if we have 2,000 fish today, what does that mean? Well, if we call today t equal to 0, let's put that into the equation. So we're going to have e to the 0, which is equal to 1. So I'm just going to be left with A0. Okay, but we also know A0 equals Y0. Y0 by assumption is going to be equal to 2,000. So A0 is 2,000. So I can put that in there in my equation. Now, not given C. That's where this business of doubling every 5 years is going to come in. So what's going to happen in 5 years? If I have 2,000 now, in 5 years I'll have 4,000. So it's going to give me the equation 4,000 equals 2,000 e to the c times 5. Okay, we divide both sides by 2,000. I get 2 equals e to the c times 5. We want to get rid of the e, so I'll apply natural log to both sides. Natural log of e to anything gives me back anything. So I'm going to have 5 times c equals natural log of 2, or c equals natural log of 2 over 5. Okay. If I go and put that back into the original equation for e to the ct, what can I do? I can rewrite that as e to the natural log of 2, parentheses, with the t over 5 on the outside. The e natural log of 2, e and natural log cancel out, leaving me with a 2. So our final equation is going to look like 2,000, 2 raised to the t over 5. Okay. Now we can start solving for things. So first, we want to know what's going to happen in 6 years. So we just put a 6 in where we had t. What am I going to get? 2,000 to the 6/5. I pop that into my calculator, and I get 4,595 fish. How long will it take us to get to 32,000 fish? Okay, so that's going to be 32,000 equals our equation. I'll have 2,000 2 raised to the t over 5. So we'll divide both sides by 2,000. That'll give me a 16. Okay, you can rewrite that as 2 to the 4th power. And if you note, we have these both to the same base. So I can apply log base 2 to both sides. Log base 2 on 2 to anything gives me anything. So this will collapse to 4 equal to t over 5. Okay, or the way to keep that organized is if you have things above the same base and those are equal, then things in your exponents are equal. Okay, so 4 equals t over 5 gives me t equal to 20 years to get to 32,000 fish. Now we can check that because the way I pick the numbers, let's see what happens. If I start at 2,000, 5 years go by. This is going to double to 4,000. Okay, that's our assumption. Every 5 years, population doubles. I go to 10 years, so we're going to double the population at t equals 5, because 5 years passes. It's going to take me to 8,000. Going to 15, we're going to double that 8,000, gets me to 16,000. And then going from 15 to 20, we're going to double our 16,000, gets me to 32,000 as promised.